Okay, with chapter 4.8, I just want to do a little bit of review first. Remember that LCD is the same thing as LCM. It's the smallest multiple the numbers have in common. In other words, look at the largest number or a number that's larger. Not the smallest number, not the GCF, or the greatest common factor. Now, what is the LCD or LCM of each of these? Remember, look at the big one. Can I take 14 divided by 7? Yes, I can. So LCD on this one is 14. Can I do that same thing here? No, 20 divided by 12 is an ugly answer. So we've got to split 20, or we could actually even look at the multiples of 20 if we wanted to. But I really, really like this format because it's the, once you get used to it, it's the easiest format. I know that 4 goes into 12 and 20. 4 times 5 is 20. 4 times 3 is 12. 4 is repeated, but we still just bring it down one time, and then we bring down every other one, all of the other pieces. So 4 times 3 is 12, times 5 gives us 60. And again, box in your answers. Now, 72 has a common factor with 60 of 12. 12 goes into 72 6 times, and 12 goes into 60 5 times. Our common factor, our GCF on this, happens to be 12, and then I times it by 5 and times 6. So that gave us, I don't remember. So I'm going to cheat and use the calculator. How about that? 12 times 5 times 6 gave us 360. And is it cheating using a calculator? No, because at chapter 4 we're allowed to use a calculator. Now, 3 goes into 18 and 15. 3 times 6 is 18, and 3 times 5 is 15. Bring down your GCF one time, and then you bring down your other factors and you multiply, and that's 30. So it gives us a 90 here. Why did I do that? Because I promise you, using the LCD with solving equations is going to be the very nicest way we can do these. So the LCD here of 4 and 20 is 20. The shortcut is you multiply all 3 numerators by 20. Now this numerator is 20 over 20, so chop chop. The right side of that equation is 1. Now 4 goes into 20 5 times. Negative 3 times 5 is minus 15. And 1 goes into 20 20 times, so that's a 20x. Now, remember with our solving equations, so chapter 3, you cannot toxic dump because you have to still use that information. The opposite of subtracting 15 is to add 15, and if you add it to one side of equals, you have to add it to the other side of equals. So chop, chop, that's gone. That leaves us 20x equals 16. The opposite of timesing by 20 is to divide by 20. And remember, the unspoken rule of fractions is that you have to reduce. So x equals 4 over 5 because I can divide 4 out of top and bottom. So x equals 4/5. Alright, and since this x is a whole number over 1, 1 times x is x, over 3 times 1 is 3, equals 7 over 1. Okay, you can actually use a slight shortcut and cross multiply here. 1 times x is x. 3 times 7 is 21. The other way would have been to multiply top on each side, and 3 divided by 3 goes away. And then x equals 7 times 3, which is 21, and 21 divided by 1 still is 21. Alright, this is a fraction over 1, or a whole number is a fraction over 1, and we can use that same shortcut here. 11 times 3y is 33y equals 1 times negative 2 is negative 2. Now the opposite of timesing by 33 is to divide by 33. And we get y equals negative 2 over 33, so that didn't clean up none. Now this one's a big fat hairy deal, and a lot of people forget this part right here. 1 is a fraction over 1. Now the LCD of 6, 1, and 3 happens to be 6. We've got 1, 2, 3 pieces, so I had better multiply 3 numerators by 6. And a 6 divided by 6 goes away, leaving x. And 6 divided by 1 is still 6, so plus, and then 1 times 6 is 6. And then 3 goes into 6 2 times. 4 times 2 leaves us 8. Are we done yet? If you said yes, wrong answer. Now, the opposite of adding 6 is to subtract 6. Why was when we said yes, why was that a wrong answer? Because x is not by itself. When x becomes positive and it's all by itself, we're done. And it is. Alright. Ooh, they're getting a little uglier. Yeehaw. And I want to just write this a little bit bigger. Okay. Our LCD of 8, 16, and 8 is 16. So I want to times all 3 numerators by 16. 8 goes into 16 2 times. And 16 goes into 16 times once. 8 goes into 16 times 2 times. Negative 5y times 2 becomes negative 10y equals, and 3 times 1 becomes 3 minus, we've already got the minus. Now 9 times 2 is 18. Now simplify either or both sides of equals. Let me scooch it up here a little bit. Opposite signs, so the rule is to subtract. 18 minus 3 is 15, and the sign of the bigger number is negative, so our answer is negative. So negative 10y equals negative 15. And see, most people hate working with the fractions, so if you kill the fractions up front, it's a nicer problem to deal with. Now the opposite of timesing by negative 10 is to divide by negative 10. Now the rule is same signs divided, positive answer. And reduce, I can divide this by 5, which is 3. I can reduce that by 5, which is 2. So that becomes positive 3/2. And now on number last, I'm going to rewrite it also, make it a little bit bigger, and change a whole number to a fraction. Now, our LCD of 3, 1, 2, and 1, the LCD here happens to be 6. So I times by 6, times by 6, times by 6, times by 6. 3 goes into 6 twice. 1 goes into it 6 times. 2 goes into 6 3 times. And 1 goes into 6 6 times. So now x times 2 is 2x plus 12 equals 3x plus 48. Now, I can't simplify anymore. Small x to big X, because we have an x on both sides of equals. So it's positive here. When I take it to the other side, I have to subtract it. So 12 equals, and 3x's minus 2x's leaves 1x, or just x, plus 48. Now, do I move my 12? If you said yes, it's a wrong answer, because there is no x with our 12. So we look at this other side. What's keeping x from being by itself? The 48. The opposite of adding is to subtract 48. And if I do this to one side of equals, I better do the exact same thing to the other side of equals. So chop chop. X is equal to opposite sign, so I have to subtract them. 48 minus 12 is 36. And 48 is bigger than 12, so we keep the sign of 48. Question? If not, enjoy chapter 4, or actually enjoy going to chapters 5 and 6.